I want you to stop scrolling and practice your optimization skills. I mean, let's be honest, there's always a good time to do a calculus problem. Let's check it out. Here's what we got. A straight piece of wire 40 centimeters long is cut into two pieces. One piece is bent into a circle and the other is bent into a square. How should the wire be cut so that the total area of both circle and square is minimized? As you can see, it's a classic. Let's go ahead and do it. So here's the problem visualized. We have the 40 centimeters for the length, and now we have the square and the circle. The 40 centimeters in this case is going to represent the circumference and the perimeter of the square. So we can say that 40 is equal to the sum of the perimeter of the square plus the circumference of the circle. And since we're trying to minimize the area, we need to find an equation for the sum of those two areas. As you can see, it's classic area of the square and a classic area of the circle, but we have two different variables. We have x and we have r, so what we need to do is rewrite this into one single variable. So we'll focus on the first equation and go ahead and isolate the r variable. And now we can go ahead and substitute this in for our r in the area problem. And don't be scared about these things, we simply have some fractions and some pi. So now that we have the equation of the area, it's time to minimize this by taking the derivative and setting it equal to 0. This is a classic power rule and chain rule derivative. I see that some pi's can cancel out on the top and bottom, and I can multiply the -2 times this 2 on the outside and try to simplify this. Now I just want to remind you, when you're trying to simplify this, to be very mindful of your fractions. It's very easy to get lost in this. Now it's time to set this equal to 0 because that is where the maximum or the minimum is going to occur. And from there we do some simplifying and we found the value of x, which is going to give us the dimensions for the square. And here I want to go ahead and take the second derivative. This second derivative, no matter what, is always positive, which tells us that this value is a minimum. So now that we have the dimensions of the square, we just need to find the radius. And from there, we just go through some gut-wrenching fractions. To simplify this, we're going to find the value of the radius. And now we have officially solved the problem. We found the dimensions of the square, the radius of the circle that's going to minimize the area.